Good morning. Today explain with my group combustion system spark ignition. My group is conformed by Hernan Toro Mojica, Juan Sebastián Valderrama, and me, Diego Alejandro Prada Garzón. Today we are going talk about one of the most important and widely used mechanical system in the world of transportation and industry, the spark ignition internal combustion engine. This type of engine powers most cars, and transportation systems on the world. This engine is important come from the fact that it combines efficiency, strong performance, and a long service life. In this presentation, we will explain how the combustion system of these engines operates, allowing us not only to appreciate the engineering, but also to understand why remains it the foundation of much today mobility. Now, explain a short story about this type of motor of engine. Sorry. The origin of this technology starts in the late 19th century in 1876 with Nicolaus Otto, patented and developed the first four-stroke engine, laying the foundation for the modern engine. However, this early design relied on careful mixtures for more stable combustion. Now, in 1902, French engineer Etienne Lenoir introduced more reliable spark plug and electric system capable to generate a precise spark, marking a birth of the electric ignition system. Over time, manufacturers such as Bosch perfect its coil, the distributor, and later electronic ignition. Um, Next, with the definition, a spark engine is a internal combustion. Um, in, in this type of engine, have a mixture of air and fuel. Air is ignited by electric spark generate a spark plug. In dice, unlike compression ignition, for example, in diesel engines, SI engines rely a controlled spark with the press moment for the start combustion. This engine typically use fuel, for example, gasoline or other volatile fuels. I can then I know for their smooth operating, quick rooted response, and suitability for the lightweight and high-speed application such as automobiles, motorcycles, small aircraft, and portable machines. For example, generators, example bombs, into other types of machines that use these types of motors. Okay, now start with main components that these engines have. For example, the air intake system. This is conformed by air filter, intake manifold, throttle body, MF, MAF, and MIP sensors, and the function of this part is supplies clean measure and air to engine. Now, next come the fuel delivery system. In this can find fuel injectors or carburetor, and in different times use carburetors. Now in the actuality use the injectors in these types of motors. Um, Pressure regulator that is encouraged by um, transport the gasoline or fuel for distinct parts of the motor and fuel lines. Either the fusion is meters delivers the precise amount of fuel. Now the combustion chamber is conformed by piston, cylinder head, valves, spark plug, and the function of this is area mixing, area where mixing the ignition, and is encouraged by the or is responsible that the combustion occur. Now the ignition system, how the spark plug, ignition coil or coil on plug, the ECU or engine control unit, have sensors, crankshaft position, camshaft position, and knock sensor. These have a function that is generate the spark and the correct time for the efficiency of motors or the best called time of motor. And finally, can see the exhaust system that this is conformed by exhaust manifold, catalytic converter, and the function is remove the combustion gases and reduce the emissions.
Now, to begin, I will explain the four-stroke cycle, which is the foundation of its ignition engine operation. This cycle covers the chemical energy of the air-fuel mixture into mechanical power through four distinct strokes: intake, compression, combustion, and intake stroke. During the intake valve opens and the piston moves downward. This creates a pressure drop that draws the air-fuel mixture into the cylinder. Airflow dynamics, such as swirl and timbre, are generated inside the combustion chamber. These motions increase mixtures homogeneity and improve the flame propagation during combustion in modern engines. Fuel may be introduced through pour fuel injection or direct injection, each influencing mixture preparation and emissions. Compression stroke. In the compression stroke, both valves close and the piston moves upward, compressing the trapped mixture. Pressure and temperature rise significantly due to near adiabatic compression. That this increase in temperature and change the mixture's reactivity, reducing ignition delay once the spark is fired. Combustion or power stroke. Near the end of the compression stroke, the combustion process begins. Although combustion seems instantaneous, it occurs in several internal phases that determine efficiency, power output, and knock resistance. Finally, we have the exhaust stroke. In the exhaust stroke, the exhaust valve opens and the piston rises, pushing the burned gases out of the cylinder. Now I'm going to talk about the Otto cycle. The definition. The Otto cycle is the ideal thermodynamic cycle used to model a spark ignition engine operation. Although real engines experience complex chemical reactions, heat losses, friction, and finite speed combustion, the Otto cycle provides essential insight into efficiency and performance. Now, I'm going to explain the process in this Otto cycle that you see in the image. First, we have point 1 to 2, the isentropic compression. In this idealized step, the piston compresses the mixture diabatically and reversibly. Pressure and temperature rise solely due to compression because efficiency increases with compression radio. This step explains why higher compression radio yield better fuel economy, although limited by knock. We have the second process, that is point 2 to 3, constant volume heat addition. This step represents combustion. In the top dead center, heat is added rapidly and nearly constant volume, causing a sharp increase in temperature and pressure. In real engines, this corresponds to the flame propagation phase, where the mixture burns over several crank angle degrees rather than instantaneously. This propagation occurs when the spark discharge, the spark plug generates a high voltage electric arc. Second, we have the ignition delay. A short ignition delay follows the spark. During this time, chemical reaction accelerates, but the flame is not yet self-sustaining. Third, we have the flame kernel formation. A small spherical flame kernel forms at the spark gap for combustion to continue. The kernel must resist heat loss to the cold metal surface and survive turbulent disturbances. And four, we have flame propagation. Once stable, the kernel expands outward. As a turbulent premixed frame, most of the energy release occurs in this stage. Now, in the Otto cycle, we're going to continue with the process, with the third process. That is from 4.3 to 4. We have the isentropic expansion or the power stroke. Here, the high pressure gas expands, doing work in the piston. This is the only process that produces net work in the cycle. Because the expansion is modeled as adiabatic and reversible, the energy of the burned gases is converted efficiently into chemical output. In the fourth process, we have point 4 to 1, the constant volume and heat rejection. At the end of the expansion, heat is rejected from the steam at constant volume as exhaust gases leave the chamber. The cycle returns to its initial state and repeats continuously. Now we have the auto efficiency inside. The thermal efficiency of the Otto cycle depends primarily on the compression ratio. Higher compressions lead the higher efficiency, but spark ignition insides are limited by knock, which restricts how much compression can be used in practical designs. Now I'm going to explain some advantage and disadvantage for spark ignition combustion systems. Advantage: spark ignition engines offer several advantages. Simple mechanical designs compared to diesel engines, smooth and quiet operations, high speed capability, suitable for cars and motorcycles, flexible fuel options including gasoline, natural gas, and alcohol blends, precise electronic ignition control, improving emissions and efficiency. Now we are going to talk about the disadvantage. However, they also have limitations. Lower thermal efficiency that diesel engines requires high octane fuels to avoid knock, higher specific fuel consumption for the same power output, less suitable for heavy duty and high load applications, sensitivity to ignition timing and mixture preparations, which can lead to knock.
Now we're going to explain the type of spark ignition. The first one, point-up ignition system. This was the first ignition system used in automobiles. It controls the timing and distribution of a spark using a mechanical switch called points. Its main job is to transform the very low voltage, that is just 12 volts, into the high voltage needed to create a spark around 200 volts. The characteristic is the advantage is the simple and low cost. The disadvantage is a mechanical wear, less precise spark timing, and requires a regular maintenance. The second one, electronic ignition system. This system was the next evolution. It used electronic components to trigger the spark, which is greatly improved reliability and time accuracy. However, it is still use a mechanical distribution to route the spark to the correct cylinder. The characteristic is the advantage more reliability than point system, better spark timing accuracy, and disadvantage is it still has moving parts, less efficiency than the modern system. The third one, Distribution ignition system. This is the motor system used in most cars today. It completely eliminates the mechanical distribution. Instead, it uses multiple coils controlled electronic by the engine control unit, the car's computer. This allows for the extremely precise spark timing without any moving parts. The characteristic is the advantage, maximum spark timing precision, no moving parts, minimal maintenance, most reliability and efficiency, better engine performance and fuel economy. Disadvantage is more expensive to repair. Now we're gonna explain the applications. Number one, transportation application. Spark ignition engines are most commonly found in transportation. They power the majority of cars and motorcycles we see every day. They are also used in many trucks, especially smaller and medium-sized ones. Every some smaller airplanes and these engines for propulsion. Industrial applications. In industrial settings, spark ignition systems are crucial for gas boilers and furnaces. These systems require a high voltage spark to safely and reliably engine the fuel air mixture, ensure efficiency combustion for heating and industrial process. Marine application. In the marine industry, spark ignition engines serve multiple purposes. There are from small to medium-sized boats and vessels. They are also used as generating sets for electrical power on large ships and for auxiliary systems like pumps and compressors. Number 4. Generation application. For power generation, spark ignition engines are ideal for portable and backup generation. They are lower cost, compact size, and lightweight make they perfect for recreational use, emergency back power, and construction sites where diesel engines will be too large or expensive. Now we're gonna explain the modern improvement. Number one, direct injection. Direct injection is the major improvement where fuel is injected directly into the combustion cylinder, rating that into the tech import. This allows for more precise fuel control and better combustion efficiently. Advantage: it's more than 15% better fuel efficiently, more power from the same engine size. Number two, turbocharging. Turbocharging used the engine exhaust gas to spin a turbine that forces more air into the cylinder. This allows a smaller engine to produce more power without increasing its size. Advantage: up to 40% more power from the same engine size, better fuel economy in the real world driving. Variable valve timing. This technology allows the engine to change when the valve open and close, and how much they lift. Systems like Honda VTEC can optimize and engine performance across all RPMs ranks. Advantage: better response at both low and high RPMs, improved power and efficiency. Number 4, compressing ignition. This is revolutionary technology that combines the best of gasoline and diesel engines, like Mazda's Skyactiv X. It uses compression to engine a lean air-fuel mixture similar to diesel, but using gasoline. Advantage: up to 30% better efficiency than conventional gasoline engines and diesel-like torque with gasoline cleanest. Number 5 and last one, hybrid system. Hybrid system combine a gasoline engine with electronic motors and batteries, like Toyota's hybrid system. They can use electronic power at low speeds and gasoline at high speed, or both together for maximum power. Advantage: up to 40% better fuel consumption in city driving and regenerative braking captures energy. In conclusion, we have explored the fantastic world of spark ignition engines from their basic operation to modern technology advances. Thanks you for watching.